This session is to focus on native C++ applications with the error detection tool within DevPartner Studio, formerly known as Bounce Checker. So with Bounce Checker, or the error detection tool, you can access it via the drop-down, the toolbar, and also through its standalone. So there is a standalone where you can go and open up an executable and run it and collect metrics, which we'll go back into in a few minutes. But the way it starts, or the way you work with it, is either through the standalone or through the Visual Studio instance. You can go in and choose the different options that you want to work with within your error detection session. So you can see there's various ones here, and there's a lot of details here that you can go through and specify. A lot of this is set by default, so it doesn't mean you have to spend a lot of time reinventing the wheel, but there will be some situations to where you want to specify certain resources to be tracked, certain modules and files to be collected, if you want to look for memory tracking, deadlock analysis, things like that. So if I go in here, this is the general settings to where you can go in and determine if you want to log events, display the error and pause, or do you want to roll right through and roll everything together and look at it at the end. You also have the ability to control your call stack depth, maximum call stack depth on errors and allocations. If you want to do API call reporting, there's thousands of APIs that are collected and reported on. Call validations, you can go in here and work with those as well. As you can see, the settings right here. If you're working with COM, there's a couple of sections for that to enable COM method calls as well as COM object tracking. If you're not, you can just have those turned off. The deadlock analysis gives you the ability to go in and see deadlocks and potential thread locks for your multi-threaded applications. So you have the ability to go in and set up those particular settings. Memory tracking, this is where you can go in and identify, do you want to do enable leak analysis only? Do you want to enable final check? Which what is meant by that is if you run DevPartner's error detection against your application without building instrumentation into it before, it's active check. That means it looks at a certain level as deep as it can without having the instrumentation. If you choose final check, you need to instrument the code prior to running the application, which I'll touch on that in a minute too. And this gives you the ability to find those deeper to find, or harder to find, I should say, deeper issues such as pointer related problems, certain memory overwrites, overruns, and what have you. Also on the .NET side, if you have a mixed mode application, what we can do is track with this particular setting for enable .NET analysis and .NET call reporting. You can actually do exception and finalizer monitoring, COM interop, and pinvoke monitoring to allow you to see the number of functions that are being called between your managed and your unmanaged code, and let you make better decisions of whether you want to continue to have those calls being made, or if it would behoove you or benefit you to ditch that component and build it within the managed realm so that everything is profiled under the same umbrella and not having the slowdown of having to use the interop. Resource tracking, this is where you can go in and specify which particular resources you want to track, which libraries you want included in the profiling. Modules and files, you can go in here and include or exclude specific modules and files, so you're only focusing on specific parts of your application that are of concern to you. Also, you have the ability with this checkbox down here to show leaks and errors only if source code is available. So if you check that, then it's going to weed out system level and other things that you may not be interested in profiling at that point in time. You also notice that you can add modules, remove them, and work with the system directories. And then finally, you can choose fonts and colors and configuration file management. So maybe you want a config file set up with error detection settings for focusing on API call reporting, maybe another one for deadlock or memory focus or whatever it might be. So you can create these config files and save them and use them accordingly. So with that, the only other step that would need to take place is to go into the instrumentation manager if you're going to do those deeper dive final check type scenarios, as I mentioned before, to find those deeper, harder to find issues such as pointer problems and overruns. Then you would want to go in here and make sure error detection is chosen in this drop down, that you've checked this box, and then choose the components that you want to analyze and look for these different types of memory pointer problems, the different type of error issues that you're looking for. So with that, then I can run this through the Visual Studio environment, or again, as I had mentioned before, I can use the standalone, which is recommended at times too, just to make things nice and easy for you. Throw in the executable from the file drop down, start the application, and collect the metrics. And the look and feel of the session file would be the same whether it's in Visual Studio or in the separate instance of the IDE here. And I can go in and look at my overall summary, which will show me the overall memory leaks, interface and resource leaks, different errors that were detected, and what have you. Then I can work my way left to right, and it will collect the memory leaks in rolled up nice and neatly in one tab. Shows me my leak here. I have leak leaving scope, leak exiting program, and a leak due to free. So I have this one leak, the total bytes, the allocation location, shows me the code in question down at the bottom. But then also I can see the call stack, including line numbers, and then I can jump back and forth real quickly and easily, and this is very helpful, with the allocation call stack to where the initial memory was being allocated versus the current call stack, again including the call trace here with the line numbers as well as the code in question of where the current issue has reared its ugly head. There could be a lot of real estate between the initial allocation call stack and the current call stack. So to be able to just have one quick little drop down and jump between those two is very helpful. So then I also not only look at memory leaks, but I can look at resource leaks, or other leaks is what the tab's called, for interface and resource leaks. So by doing that, it gives me the ability to go in and see that in this case I had a resource leak of a create bitmap using the GDI32, and shows me the allocation, location, the quantity, and the deallocator. Shows me the code in question again, as well as the call stack including line numbers. So I can drill in and find those details, as well as being able to look at interface leaks. So let me go to the code for this particular interface leak. Should only take a second. And once we get there, I can actually go in and see the code in question, but also on the right hand side I can see a reference count and object identity view. So it gives me the details about that component, but also if you notice here in this graph I can actually see the spike and fall of a graphical representation of my add references and releases. So I can go in here and click on any of these points in here and actually see the details about that add reference, and then I can go in and see the call stack including line numbers where applicable. So it's very helpful. So not only does it look at memory leaks, but it can look at resource as well as interface leaks and report that information to you. Then we get into the error side. This is where I can go in and it's nice and neatly rolled up all the different errors that have been detected, such as this API failure. On the right hand side you'll notice that there's parameters to show and return values reported. I also can look at the call stack, including line numbers and file names, and the code in question. I also, here's an example of a dangling pointer, same type situation, where I can see the current call stack, but in this dangling pointer, by using this, again, be able to jump between the different stacks is really helpful, because I can see here's my current call stack where the issue showed up, but I have my allocation call stack and my deallocation call stack on top of the current call stack. So it's very helpful. Then the .NET Performance, this was an exclusive example of native C++, but had I used interop, pinvoke or what have you, then I would have a list of the number of functions, the number of times those functions are called, and then the sequence. So I'd be able to go in and see, wait a minute, there's a lot of calls taking place right here. It might benefit us to no longer have this architected this way. So just a way to help make decisions. And then we have the module load events, including dynamically loaded DLLs and modules and what have you. I can go through here and see all the modules that are on this machine when I collected this session. So I also have one that I like to point out here to where I can see there's a discrepancy between the preferred and the actual load address. So then I can choose it and get all the information about that component and see all the details about the actual and preferred load address. So I may want to rebase or relocate that to help with performance depending on the situation. And then finally is the transcript, which again, this is an optional setting that you could choose. Do you want to have a full transcript reported, collected and reported, or not? Then you could just choose that, checking that on or off in the settings that we looked at earlier. But in here, what I can do is I can see where my machine, my process, and my thread have started, but then I can jump in and choose next leak or error, and then what it does is it takes me right down to my first issue, which in this case was that dangling pointer we looked at earlier that allocated by Malik has already been freed, showing me again the call stack and code references and details up at the top for that pointer problem, or that pointer issue. So now I can see from the big picture, having all these events parsed and put in order of execution, what led up leading to this issue. So then I can follow these iMaliks, this dangling pointer, and then from here I can just right click and choose next leak or error, and then boom, it takes me down to the memory leak due to free, and then I can go back and look at my address and releases building up to that issue, and I can continue all the way through. So again, what this does, the DevPartner error detection, formerly known as bounds checker, whether you use it through Visual Studio or through the separate IDE or from the command line, because it can be used from the command line just like all the other tools within DevPartner Studio, gives you the ability to really have control and focus on your application to find out where your memory leaks are, your other leaks, your resource and interface leaks, as we've mentioned before, different types of errors, including potential and existing thread lock detection, interop and pinvoke, .NET performance interaction, module loads including dynamically loaded, and the transcript. And this gives you the ability to hone in on these issues that would be very hard to find manually, automate this process, roll everything up nice and neatly, and give you the ability to find these particular issues and go in and resolve them quickly and easily.